Welcome to this part of the lesson in which we're going to be working through these questions here. Now, these questions are different to what we've previously seen, so let's slowly read through them and see if we can spot the difference. Okay, so it says, find a sequence of transformations that takes this to the graph this. Now, what do you notice? Well, the graph that we're starting with looks like it's already been transformed. And we're going to be changing this graph to look like this graph. This graph looks like no transformations have been applied to it at all. Now, that statement I've just made could be challenged because everything's relative, right? It depends on where you're starting from. We're starting from here and we're going to this. So therefore, this graph is the transformed graph, even though it looks like no transformations have been applied to it. It's all relative. But for our simple minds, the way I like to think about it is I'm starting with this and I have to undo the transformations that have been applied to it. I'm doing the reverse to get rid of these things here, like this +6, this -1, this 3. I need to get rid of those by doing the opposite transformation to get it to look like that. Okay, so with that introduction, let's now get into it. Remember, there are two ways of approaching these types of questions: by inspection and by the method. So let's begin with by inspection. Now, when doing these types of questions, when we're moving from something that looks like this to something like this, it's like going into the bizarro world. Everything that I've said is true all of a sudden comes into question. At the end of the day, as long as your maths is correct, that's all that matters. So remember, when you're doing something by inspection, normally the first thing you always have to do is make sure you factorize inside the function first. Thankfully for this question, there is no factorization involved, so we don't even have to look at that. In the next example we go through, we'll talk about the necessity of factorization. But for this, we just have that. Now, normally when we're doing these types of questions, we go dilations first, then reflections, then translations, right? Well, as I said, we're in the bizarro world now. We're actually going to do the opposite, and this is the case many times when you are going from a graph that looks like this to one that looks like this. You do the opposite way. So that means we'll first begin with our translations and then go with our reflections and then go with our dilations. It has to do with the question of factorization, but let's not go too deep into that at the moment. We're going to do our translations first. Okay, so let's get into it. The first thing that I want to do here, what is the first thing I want to do? I want to get rid of this 6. So if this has been, this graph at the moment, this +6 means it's been moved 6 up. Well, I want to move it 6 down. So that means I'm going to translate 6 units in the negative y direction. So by doing that, it's like I'm minusing 6, right? So that goes away, and I'm one step closer to making my graph look like that. I'm also going to have to do the same thing over here. So at the moment, what's happening here, this -1 is saying, hey, move the graph 1 unit to the right. Well, to undo that, I'm going to have to move it 1 unit to the left. So I'm going to have to +1 here. So, and 1 unit in the negative x direction. And by doing that, I'm getting rid of that. And again, I'm one step closer to making my graph look like this. I now need to get rid of this 3. Well, what is that 3 doing? That 3 is saying perform a dilation by a factor of 3 from the x-axis. Well, to undo that, I'm going to have to perform a dilation by a factor of 1/3 from the x-axis. Now you're going to need that all-important word then, and then we're going to say then a dilation by a factor of 1/3 from the x-axis. Oops, that's not how you spell x-axis. Perfect. And by doing that, that 3 will cancel with that 3, and now my graph looks like that. Okay, hopefully all of that made sense. There were so many things that are different here that might be a bit confusing. The fact that we did our translation first and just other things, we're doing the opposite, it seems confusing, but with practice, it will all become straightforward. Also, when you're doing your questions, you don't have to put in this stuff here. I just did that to show you what was going on. Let me just quickly tidy that up, that and that. All right, there's our answer. We're done. But let's now go through an alternative way of answering this, and that is using by the method. So let's come over here. Whoopsie daisy. And let's now go by the method. So this is going to be a different way of getting the same result. Remember, when we're doing by the method, we start with this. I'm going to a new point x dash y dash. Now, writing this out can be helpful when doing this because we have to be mindful of what we're starting with and what we're ending up with. We're starting with this and we're going to this. So that means this right here is my newly transformed graph, and this is my original graph. So as I come down here now, on the left hand side, I put this. Let's just make sure I write this correctly. X minus 1 squared plus 6. And then on this side, I put this. So notice how that is different to what we have previously done. And it's because we're moving in the opposite direction this time. That means our dashes go on this one right here. It's trying to disappear on me. There we go. That's also important. The next thing that we do is what we normally do, and that is we come here and we rearrange this in order so it looks like this. So to get rid of this plus 6, I'm going to minus 6 to both sides, and then I'm going to divide this side by 3. So I'm going to end up with this on this side, 1 over x minus 1 squared, and then over here I've got y dash is equal to 1 over x dash squared. Now, the next thing that we do is I equate this with this, and then I equate this with this. All right, so let's now do that. I go y dash is equal to y minus 6 over 3, and x dash is equal to x minus 1. Okay, let's pause and reflect on something very important. When we're doing by the method, the whole point is to find out what x dash and y dash is. Well, as you can see here, I'm done. I figured out what x dash and y dash are. Normally, in previous questions, we've had to rearrange. But now, because we are going in the opposite direction, y dash is this and x dash is that. We're done. But now, this is where we're going to have a bit of a discussion as to the order of our transformations, and hopefully it will clear up why we did it this way as opposed to that way. So buckle in. This is going to take some time. What I want you to do is I want you to just halve this. Is that half? Well, it's good enough. And I'm just going to be showing you alternative ways of doing the same thing. So we'll call this alternative 1. And this will be alternative 2. Same answer, both of them are going to be correct, but they're just alternatives. Alright, so we have xy, and I go to x dash y dash. So I have xy, and I know that x dash is this right here, x minus 1, and I know that y dash is going to be this, y minus 6 over 3. And now I can read off the transformations that are occurring here. So let me grab a black pen and we're just going to read it off. Now, we have to read the translations first. And the reason why we have to read the translations first is because, do you see here, the very first thing that happens to my y is I subtract 6. Then I divide 3. But the first thing that happens is I subtract 6. That's the first thing that happens to it. So that means a translation is happening first. So I'll come here and I'll write translate 6 units in the negative y direction. And then we always do all the translations at once. So I'll come over here. This -1 here is telling me I'm moving 1 unit in the negative x direction and 1 unit in the negative x direction. Okay, now after we've done the translations, the next thing that happens is I divide by 3. So that means that the next thing that happens is I perform the dilation. The next thing that happens, first I did the translations, then I do the dilations. So remember that all important word, then dilate by a factor of 1/3. Sorry, yeah, a factor of 1/3 because I'm dividing by 3, so it's a factor of 1/3 from the x-axis. Okay, so let's just go through that. It all had to do with how I wrote it here. Because I went y minus 6, that means the first thing that happened was a translation of 6 units in the negative y direction, and then I had a -1, so 1 unit in the negative x direction, and then I had this divided by 3, so then dilate by a factor of 1/3 from the x-axis. So we did our translations first, and that's what we did up here. That's what we did up here. So let me just highlight it up here as well, so you can see I translate 6 units in the negative y direction and 1 unit in the negative x direction, and then a dilation by a factor of 1/3 from the x-axis. And that's what we saw down here. Now, let's go through alternative 2, where the sequence is going to be different. Hopefully I'm not losing anyone. I know this stuff can be a bit tricky. So I've got xy, and I'm going to x dash y dash. I've got xy, and now, there is another way I could write this. Well, actually, before I do that, x dash is easy. It's just x minus 1. That's the easy part. The part where this gets tricky now is, see this? Y minus 6/3? I can write that in a different way. I can break up the denominator. I can say I have y/3 minus 6/3. That's the same thing. It's the same thing. And of course, we're not going to write 6/3. We know what 6/3 is. It is 2. Now, really focus on this. Focus on how this is different to this. The reason why it's important is because it changes the order of the transformations. So let's just get rid of those black boxes for a second. Here, the first thing that happens to my y is I divide it by 3. So that means the first transformation that is applying here is a dilation. So dilate by a factor of 1/3 from the x-axis. Now, when you do that, when you dilate by a factor of 1/3 from the x-axis, it changes what your translations are going to be. The next thing that happens is I then have a translation of 2 units in the negative y direction, and then 1 unit in the negative x direction. That's the least important thing. But do you see how it changed things? If you look here, the first thing that's happening to the y is dividing it by 3. Then I'm translating by 2 units in the negative x direction, negative y direction, sorry. So then I would say then translate by a, translate 2 units in the negative y direction and 1 unit in the negative x direction. Okay, so let's now just stop and look at what we did there. I first dilate by a factor of 1/3 from the x-axis because that's the first thing that happens to my y there. and then I translate 2 units in the negative y direction because of this, and 1 unit in the negative x direction because of that. Hopefully that makes sense and explains why the order can be different, and explains why we went why we read the translations off here first rather than the dilations. It really comes down to the fact that by getting rid of the translations first, we can then just deal with the dilation by itself. If you do the dilation first, do you see how it impacted what the translation was? Now it's 2. But if you're looking at this, you know, it's not clear that we're having a translation of 2 anywhere, but it's because we've done the dilation first. So that's why we did the translation first there. Okay, hopefully all that makes sense. Come speak to me if you are confused by it. This is a tricky part of the math methods. So make sure you come find me if you find this tricky. It has to do with order, it has to do with rearranging stuff. Hopefully you found this useful, and I'll stop here and then we'll go on to this one in the next part of this video. And the reason why this one's a bit different is because there's the question of factorizing as well. This one we were spared of that, thankfully. But now the question of, well, if I have to factorize to do this stuff, how does that impact it? Hopefully you found this useful. I'll see you in the next video.